Good morning, everyone. I'm Sendil Kumaran C from the 2022 to 2026 batch, team number 310. Today, I'm presenting my mini project titled "In Intelligent Assistant for Mental Well-Being," developed under the guidance of Dr. G. Arul Dalton from the Information Technology Department. Now, let's move on to our agenda. Our presentation today covers 9 key areas: introduction and problem statement, project scope and detailed methodologies, system design including use case diagram and class diagram, and implementation details like machine learning and system design implementation, and key code components. Finally, we will review the result and the conclusion and future enhancement. Now let's move on to the introduction. The primary goal of this project is to provide an intelligent and accessible digital platform for the mental well-being. We aim to offer the space where individuals can express through without fear or judgment, overcoming traditional barriers like high cost and social stigmas. Key features include continuous mood monitoring, personalized suggestion, and immediate guidance during mental struggles. Now let's move on to the statement of the problem. Currently, mental health issues are rising due to the fast-paced life cycle, yet many hesitate to seek the help, and because of only stigma and financial barriers. These are also the significant shortage of the qualified professional, leading to treatment delays. Our assistant addresses these gaps by providing timely assistant, yearly stress identification, and reliable self-help tools. Now let's move to the scope of the project. The scope of the project involves in creating an AI-based performance for sentimental analysis and yearly stress detection. We focus on providing personalized recommendations like relaxation exercises and motivational contents while ensuring all users communicating remains secure and private. We also store the interaction histories and provide long-term mental health insights, ensures error-free user experience through the validation checks, chatbot feedback messages, and smooth navigation, designed to assist a large number of users by offering a scalable emotion support and guidance simultaneously. Provides a user-friendly interface accessible on multiple devices such as smartphone, tablets, and computers. Now let's move on to the methodologies. Our methodologies is broken into several phases. Analysis and design is of one phase, and database is another phase. Like that, implementation and testing are some other phases. Uh, Analysis and design phase: identifying the user roles and designing an architecture that includes AI and NLP modules. And another one is a database phase, normalizing the data to securely store the moods log and the conversation histories. Implementation: building the front end with the HTML and JavaScript, and back end with the Python Flask and NLP libraries like NLTK or transformers. Testing and maintenance is one of the phase, ensuring accuracy through the system testing and continuously updating the system with fresh mental health contents. Now let's move on to the system evaluation feedback. Evaluation feedback: gather the user feedback through emotional support, quality, and chatbot responsive and easy to use. Like this, the feedback will be gathered from the user to refine the AI models and improve the recommendation based on the user interaction and performance evaluation. Deployment: host the system on a secure cloud server or deploy as an web application. Configure the necessary services like secure API login and communications and database connectivities for the real-time accessibilities. These are the key concepts involved in the methodologies. Now let's move on to the system architecture. To structure the system, we used a UML diagram. The use case diagram defines the boundaries between the users and the admin actors. For the users, this includes the boundaries between the admin actors. For the users, this includes chatting and mood tracking. While admin manages wellness content, we also developed a class diagram and a sequence diagram to map the logic of the interactions of the data flow, where the class diagram is used to represent the structure of the system by showing the classes, attributes, operation and relationship among the classes. In this project, the class diagram illustrates how the chatbot users and sentiment analysis admin interact to provide the mental well-being support. It defines the key components and functionalities required for the emotional detection and secure interaction mental health resource management. Instead of modeling every individual user's generalized user class represent a user interaction with the AI system. Here the use case diagram for the system design, where where the user will interact with the AI chatbot. Based on the interaction, the output will be categorized. Either he can consult with the therapist, or the result need to be overlooked by the administrator, or it can be categorized into the monitor system performance based on the feedback provided by the client or the user. Through this, the system design, the user can be categorize their result of activities by their interactions. Now let's move on to the design class diagram. Based on this design, the user can get their information. They can give their information to the chatbot. Based on the information, it can be categorized into either they are really sad or happy. This categorization of the emotion, which helps to give the remedy for the users. Now let's move on to the sequence diagram, where the user provides the information regarding their mental health. While the mental health information has been gathered, the mood tracking analysis will be carried out. Based on this mood tracking analysis, keyword detection or any other through this detection, the solution will be converted as either sad or happy. Like this, we can categorize the solution based on the detecting keywords. After the detection, uh, without any collision resistant, the user will get the output, and either by dashboard or retrieve the histories. Now let's go to the sequence diagram. Malware detection using machine learning example, where the user will browse the AI product and select the product. After the selecting the product, the AI must need to send the information regarding the product where the user has been selected. The information has been fetched from the product details, and through this product details, it has been displayed to the users. This sequence has been completely explained in this sequence diagram. After that, now let's move on to the implementation. The implementation, our core logic relies on the sentimental analysis, and the backend categorizes input into the positive or negative labels. The sentiment is mapped to the recommended activities. For example, if the user feeling anxious, recommended 4 to 7 or 8 breathing, while happy, user is prompted for gratitude reflection. We are also implement the dashboard to visualize the mood and trend over the time using the chart data. Now let's see the key components. The key components included in this projects are: for the code, is NLP processing modules, sentimental analysis modules, chatbot response generator. NLP processing modules intended understanding the emotional keyword extraction. Sentimental analysis module used to trigger the suitable response or recommendation. Chatbot response generator handles fallback response and unclear inputs. Now, what are the algorithm used? We have been going to discuss here. Emotional and input processing algorithm, sentimental and emotional detection algorithm, mental well-being response generator algorithm are being used in this project for the detection of the mental well-being of the user. Now let's move on to the hardware and the software requirement. For the technical stack, we utilize Fast API for the backend and React plus VITE for frontend. The AI logic is powered by Hugging Face Transformer for sentimental analysis. Hardware wise, the system runs with a standard i5 or i7 setup with 8 to 16 of GB RAM support in a hardware wise system requirement. And now let's move on to the implementation. uh, Implementation of the code. System analysis act as a brain. In this slide, our assistant process the user input to the understand their mood. We use the post request. We use the post request to we use the post request called API analysis. When the user sends the message, the system scans it. This helps to scan the message that user gives to the AI. After scanning the message, it will be categorized in either positive or negative words based on the keyword that has been captured in this message. If the keywords included sad, anxious, tired, angry, stressed, and depressed, these are the keywords that is going to categorize that the message is either negative or neutral. If the happy, excited, grateful, proud, and confident, relaxed, these are the keywords are going to represent the positive type of mindset of the user. Based on this, the negative and the positive mindset will be calculated of the user. After this, we need to, if there is a no positive or negative keywords, we need to categorize it using the iterative statement. Based on this iterative statement, if the value of the result is either above 1 means it is positive, or below the 0 means it is negative, or else it is neutral. Neutral is a normal pace where the user is neither positive or neither negative mindset is classified into the neutral phase. This sentimental analysis act as a brain. And now let's move on to the saving, logging and memory. This act as a brain. This act as a memory for the brain. Once the mood is identified, we need to save it so the user can track their process over the time. We use post method called API moods. In this, we will get endpoint to create a mood entry. Each entry has records 5 key details: a unique ID, the mood name, and the sentiment score, and the activity the user completed, and the timestamp. This data is published or pushed into the history logs, ensuring that every session is recommended for the future analysis. Now let's move on to the where sentimental analysis is a brain, and logging and memory is memory mapping or mood mapping is act as a memory. And now let's move on to the activity mapping act as an heart of the activity mapping act as an heart of the AI chatbot. This is a core logic this is a core logic of our assistant. We have a mood map that matches a specific emotions to helpful activities. If you are anxious, the system suggested 4 to 7 or 8 breathing exercises. If you are sad, it often it offers a positive affirmation. If you are neutral, it might suggest a mindful to take a tea break. This mapping ensures the help provided is always relevant to the user how it feeling as a exact moment. Now this act as a front end brain. Based on the sentimental analysis, it will be gives the positive affirmation, body scan, meditation. This and all will be given through this mood map. Now let's move on to the dashboard and visualization. The feedback area. This act as a feedback area. Now finally we have turned all the data into something the user can actually see and understand. We use the mood trends line chart. We convert the sentimental into the scores, +1 for positive and 0 for neutral and -1 for negative. By plotting these scores against the time, the user get a clear visual map of their emotional journey. It simplifies the users identify the pattern and see if their mental well-being is improving over the week or not. So this is output for our mental well-being AI chatbot, where now when we click the chart, start your journey, it will shows this page. Whether to check our mood, we need to enter the details or information here. Through this we can analyze our mood quality here. Based on this information, it will give either you are a sad or a good or a happy person. Based on this, the output will be generated. This dashboard is a mood trends time chart. It will calculate the time over the month or a week. This graph helps us to check the details of the users of their moods. Now let's access their test cases. Number one is action checks the mood input. Okay, after the checking, based on the input, the output has been generated. Based on the output generated, actual output has been passed and the result has been carried out. Like this, the test case, several test cases has been followed and taken. So in conclusion, I am concluding this session. Based in conclusion, this project demonstrates that AI is driven conversational system can effectively component traditional mental health support by offering 24/7 availability, and this assistant helps the users build the self-awareness and emotional regulation in safe and non-judgmental environment. Now the future works. For our future enhancement, we plan to include multilingual support, wearable integration, and crisis detection are our future works. Now based on this, the AI driven process tracking gamified well-being activities will be encouraged through this future work. Now let's move on to the implementation of the code. So this is our AI chatbots code preview. After running this code through npm installed commands, we will get the output like this. Localhost will be hosted. After that, we need to click start the journey, and we need to enter a prompt, either information. Today is holiday. So by entering this command, it will segregate my mood into a neutral. Today is on a holiday, is a neutral phase for the being. Based on this neutral, it gives me the suggestion we need to convert the mind neutral into happy one. Now we can track my progress here in the dashboard. For first day, there is no tracking. If we track for an year or a month, it will show a timeline here like this. So with this, I am going to complete my video here. Thank you for watching.